Think we are live now. Let me just give it a minute or so. Cool. So I didn't really announce this live stream. In fact, let me go ahead and just put it on Twitter. Let's go ahead and put it on Twitter. Let me go back to this tweet over here. So we're going to demonstrate something in a little while. Just going to tweet from Rhizome. Don't think many people are going to show up, but I just wanted to do a spontaneous live stream. Why not, right? So lately I've been really digging into building stuff on Icon. As you probably know, we're working on Project Coda with the Tempo team, and I'm just trying to get more familiar with the technology and the capabilities of it. I was kind of playing around with the software development kits for a while, mostly the Python one, maybe like the past, I don't know, year and a half or so. But recently I started digging more into the smart contract side of things and, kind of understanding how to build directly on the blockchain. So, the token standards and all of that. I've been really excited about the IRC31 standard lately. For those who don't know, that's called the multi-token standard. And it basically allows you to mint a lot of different tokens with different properties with one single contract. So the other token standards like IRC2, IRC3, and IRC16, they all require you to deploy a separate contract for each token that you mint, which can get which can be a problem. I can't even say that word, problematic, which can be problematic if in certain use cases, right? So imagine if you're trying to mint a lot of different NFTs that represent different things in a game. You might have one that represents a sword, you might have one that represents a shield. If you had to deploy a smart contract for each of those items, it would get very costly because, on Icon as on other blockchain platforms as well, deploying a smart contract costs, I won't say a significant amount of money, but if you're doing it for hundreds or thousands of items in certain use cases, it could quickly add up. So I think on Icon, I don't know exactly on mainnet what the price is for deploying a smart contract. I think maybe it's like 50 ICX or 30, or don't quote me on that. It's something in that range. So, if you had to deploy 1,000 of those at 50 ICX each, it's just not economically realistic. So IRC31 sort of tackles that. It lets you deploy one contract, and within that contract, you can mint as many tokens as you need. Each token is referenced by a unique identifier. So I was getting sort of more familiar with all of this stuff lately, mainly for Project Coda, but I was also interested in working on some of my own things and building out these projects that I don't really intend to monetize, but to practice my skills and to sort of show people what I see as practical use cases of blockchain. And I really want to get the point across that anyone can get started with building on Icon. It takes a while to sort of set up your local environment and all of that stuff, but after all of that is set up, it's actually a pretty good process, I think. And I want to also stress the fact that you don't have to come in as a developer, quote quote developer, in order to build something on Icon. I'm not a trained developer. I've kind of been a nerd for my whole life. I like building websites and things along those lines, but I didn't go to school for computer science or anything like that. Coding was never something I truly studied in depth, but it's something that I've kind of picked up along the way just because I have an interest in trying to build things out, and often it's easier to get started building on your own than to try to reach out to someone and convince them of what you're thinking about and going that way. So I just want to kind of show something that I've been working on. Again, I don't think this is something that I'm gonna necessarily try to make an income from or something like that, but it's a fun project. I think that kind of demonstrates how the Icon blockchain can be used in a real world context. So I just want to show you guys this thing. There's this service called TweetStamp. It's basically a service or a bot that lets you timestamp tweets, and it's on the Bitcoin blockchain. So you have kind of all the issues or inefficiencies that come with doing stuff on Bitcoin. Just can't timestamp a whole lot of data in regard to file size, and compared to Icon and other proof of stake blockchains, it's a bit slower, So the idea behind this bot is you DM this bot with a link to your tweet, I guess, and then it'll timestamp on the Bitcoin blockchain using this thing called Open Timestamps. It's this thing that was developed by Peter Todd, I think. So I was kind of thinking about something similar on the Icon blockchain, but more of like a version 2, because with smart contracts and token standards, all of these great things that we have on Icon, I think there's a better way to represent what a tweet is. So I was looking at it and thinking about it, and it's like each tweet has a unique identifier. So if we're looking at this tweet from Min, you have this identifier, this 19 or 20 character long number that is actually unique for each tweet. So no two tweets have the same ID, and I think actually if you just change the username as well to anything, it'll actually bring you to this tweet as well. So what that tells us is that Twitter uses this ID to reference tweets within their product, and the username doesn't really matter. So now that we know that the ID is unique for every tweet, and we know that the IRC31 standard lets you mint tokens, and each token has a numerical identifier. What that means is we're able to represent this tweet with an IRC31 token And for each tweet, we can just use the identifier that Twitter has assigned. Because again, no two tweets will have the same ID. So I was kind of going on this, I was kind of going down this path, and was working on an API right now. I'm actually working with someone in the community to just do a simple front end. Again, the point of this is to show show the community like how easy to build it is, how easy it is to build on Icon, as well as maybe not every single product has to be DeFi or all these, I guess, financial kind of things that are coming out on blockchain. Like a service that lets you timestamp tweets is a very valid use of blockchain. If you want to, if you're trying to comment on someone's tweet, for example, if you want to embed their tweet into a blog post or something, and the context of the blog post is based on what's written in that tweet. If the user ever deletes that tweet, that would potentially make the blog post confusing. The context would be gone. So if there was a way to timestamp the tweet, and as we'll see later, once it's timestamped, you can build some sort of additional API to grab the data from the blockchain and use that as the embed instead of the embed directly from Twitter, then that gives you a way to preserve the context of the blog post as long as the host blockchain is alive. And I think that established blockchains like Icon are going to be around for a long time. Certainly objectively much longer than the time frame where someone may or may not get rid of a tweet and mess up all of the embeds. So that was the premise that I was going on, and so I put together this little API here in Python, and I want to keep this short. I want to. It's pretty nice out today, so I want to finish this up in 10 or 15 minutes. So I don't want to dive too deep, but basically I have a tweet class here that has all of these different functions in here that basically represents all of the stuff that I need in order to represent a tweet. So this takes the tweet URL as an input, and the idea there is someone would go to this interface, they would copy and paste the tweet URL that they want to timestamp, and then that would be the input into this API. So I'm expecting a tweet URL here, and there's functions to do a bunch of different things like extracting the tweet ID, extracting the tweet user, extracting the tweet body. So that would be the body of the text, and that's done directly from the Twitter API here. And there's a function to generate a tweet image URL and converting that tweet image into a string. And there's this like thing here that just checks if it's a valid tweet or not. So this class is representing kind of the input tweet and also some functions that need to be done to that tweet before tokenizing. So the next class I have here is tweet token. This expects a variety of different things. Yes, I have a test key store here. I would never do this in production, of course. It's probably best to store these in the environment itself, but I don't intend to deploy this live anytime soon, and I'm only working on my local T-Bears setup here. So, oh hey, speaking of people I'm working with, here is Yi Ji. Sorry if I'm saying your name wrong. Um, YJ, I'll just call you YJ. He's actually helping me out with the front end for this thing. So uh, go ahead and follow him. I don't know where you can follow him, but go ahead and find him and give him some love. So I have a smart contract address here. As you can see, I'm only working on my local host. Oh, hey, Fez. We've got crypto setups in here as well. That's Fez. So here's my tweet token class. So this class contains some of the functions that I'm using to actually mint the IRC token. So it expects a few different parameters as inputs, tweet ID, tweet user, tweet body, tweet image. And there's many different functions in here that I wrote. So, this checks if the token is already minted. This checks, this is getting the URI of the tweet, so I'll explain that later. And we have a few different utility functions here, and this is the actual minting function here. Yeah, so this kind of contains the stuff to actually mint the token. So before I kind of demonstrate this, I just want to talk a little more about exactly what IRC 31 is. It lets you mint a token with specific characteristics. So, things like the ID, which is the way that you reference the token. So that has to be a number, and then you have what is called the URI. The URI is basically just pointing to a location where you store a JSON file that describes what that token is. So it actually will contain the information like the name of the token, the description of the token, and stuff along those lines. And typically, I've seen that people have been uploading this URI file to a service like IPFS and things along those lines. I actually don't know if that's a good idea, because if the data that is representing your token is not stored in the same place as the token, so that would be like the database that we call the Icon blockchain. It's a decentralized thing there, right? If it's stored on IPFS, it's somewhere else. It's not within Icon over here. So what I've actually been doing with Project Coda and with this tweet thing as well, I've actually been storing that JSON text as an additional transaction on the Icon blockchain, and using that transaction hash as the URI in order to mint this IRC31 token. So what that allows for is basically all of the data that is needed to understand what this token is all within the Icon blockchain, the Icon system. So there's no need to rely on external providers. I think on IPFS, the storage is not really guaranteed. If no node on the network wants to store your stuff, then I haven't looked into it too much, but the idea there is like, I'm not sure what's going to happen if no one wants to store my stuff. So if we can keep it all on the Icon blockchain, that would be great. And I think this is also a very good implementation of storage for people who want to issue non-fungible token artwork on the Icon blockchain. You can embed the image, convert it into like a base 64 string. You can actually store the image into a transaction so you don't have to upload it to IPFS and somewhere else. That's a major issue that I see people talking about in Ethereum. And the idea there is like, what happens to this NFT that you have if the storage for the artwork ever dies or the file gets lost, right? So um, that's why I like to store the data on the Icon blockchain directly. So I'm just going to go ahead. Let's take a tweet here. I'm just going to grab this tweet from Min. So I'm going to copy the URL. And I'm going to go here. So this is going to send a post request to this timestamp tweet endpoint here. Hopefully this works. This was working like 10 minutes ago. Great, it worked. So Crypto Setup says, would that not impact the size of the chain if too much data gets added to it? That would impact the size of the chain, but storage is cheap. And if that is a real concern for the blockchain, then I assume that the PREPs would be able to vote maybe to reduce the maximum storage size of the transaction. Right now, the maximum size I think is over 200 kilobytes. So if the limit is set as that, then it means anyone is free to use that storage. So of course it would impact the size, but I don't see it as a huge issue. And if it ever becomes like a huge issue, then there can be things that can be done to address that. So we have a successful minting here. We have a few different responses here. So this is the transaction hash of the mint. These were the different parameters that were used for the mint. So we can see that the ID of the tweet is here. This is the URI. Again, the URI is a metadata file that describes what this token ID is. And we have the username and the supply. I have it set as 1. So if we take a look at this transaction hash here, give me 1 second. Just have to respond to a text. Okay, if we take a look at this transaction hash here, right, so we can see this was the transaction hash. This was basically the transaction that was minting the token, So it made a call to the smart contract here, and it minted a token with this ID with supply of 1. This is the URI, and we just have the username here. If we take the transaction hash of the URI, we can see this here. Okay, so what's happening here, right? There's a lot of things going on here. All of this, this stuff here is actually the image. I'm generating an image of the tweet and embedding it into the metadata file as part of the JSON. So let's just go ahead and disable that real quick, so you can actually see the file. Actually, no, we don't have to do that. I have an endpoint. Okay, so if we just go over here, get tweet data. So this endpoint I made actually returns the stuff that was timestamped in the URI transaction. So that would be like the JSON containing the information like the name the description and things along those lines, the actual tweet body. So if we go ahead and do this here, great. So this data down here is actually being fetched from the Icon blockchain. And this is stored on the Icon blockchain so it's not so it is tamper proof, we can objectively say that this data existed at this time, and that's the whole point of this, right? So this is a name. I was just using the token ID for the name. This is the description saying this is a timestamp tweet by Minho Kim, and this is the original URL. This is an image here encoded into base64 format. So if we go ahead and actually copy this, we would get something that's similar to this. Okay, so this is just, if we look at the source code here, we can see that this is just also a base64 image. And if we are able to pull this string here and display it in a browser, you would actually see an image of this tweet. So that's useful, because then you could build a layer that could actually pull this image and display it on a website. So that would be a way to embed a tweet in a tamper-proof way. Scrolling down here, these are the actual properties that I put in. So you have the author ID, conversation ID, the creation time of the tweet, and also the text of the tweet, and also the source. So this was made on the Twitter for iPhone. So instead of grabbing the image, if you had some sort of layer that could take these different properties and dynamically create some kind of embed in real time, that would work as well. So that's it, right? Like, this is not some huge project, but I think that it really demonstrates that anyone can get started with building on Icon. You don't need to go to school for 8 years to learn how to code. You can really just dive in. If you're just getting started, you want to work on like backend stuff and also the smart contract stuff. I would definitely recommend just learning, basic to intermediate Python. You can really get started quickly with Python, and smart contracts on Icon are mostly written in Python, and it's also a great language for building the back end services of various apps. So that's like a cool way to get started. It's fairly easy to get set up in regard to like the local dev tools. If you ever have a question, you can log into Telegram. There's an Icon Devs group. I think there's also an Icon Devs Twitter account, so you can always probably tweet out there as well, or you can reach out to me. I'm not an expert, but I'd be happy to help as much as I can. So yeah, that was kind of a small demo of how you can use Icon to timestamp tweets using the IRC31 standard, and how easy it was to really get this built. I started working on this as in my very limited free time, maybe 4 or 5 days ago. So it was a pretty quick process to get to where we are now. Okay, yeah. So that's all I wanted to talk about today. I just wanted to share and hopefully to encourage more people to try to start building. I think once you get familiar with the tools, then the ideas will just keep flowing, because you really are able to see what's possible. And if you don't see what's possible at first, it's hard to really envision a product that you can build. So yeah, If you have any questions, feel free to reach out, and hope you all have a nice day.